So I'm Justin. So I'm actually talking about WebAssembly and how I found that it could be kind of used in interactive art installations. So for a bit of background, for the last couple of years, I've been working with artists to build art installations. So they come up with the why and I come up with the how. So for example, this work was a bunch of solenoids activating bells. And when people walked around the installation, the bells rang because the solenoid hit them. So this was a really rushed job, and it shows because it was a bunch of prototyping boards and not proper PCBs. So your standard ESP32s hooked up to a whole bunch of modules. So throughout these multiple projects, I keep thinking of how do you actually reduce the amount of effort needed to build these works? Because when it comes down to it, there's just not enough time and not enough funding to justify building out the whole work over and over again. So I keep looking at this and figuring out how do you iterate faster? And so Arduino everywhere, right? Can I do it? Sorry. You don't want to see this thing. I can move it. I can hide floating. Okay, yeah. So Arduino everywhere, right? You build them under time constraints, and you kind of redo everything over and over again, I found. So this is because the setup kind of varies from installation to installation. So you might be grabbing a ESP32 on one setup, but you might not be able to get enough units for another work. And you have to grab a whole bunch of Arduino Nanos, let's say. And you can't really run a consistent code base with your utilities when you do this. So I found that there are a couple of sort of quality of life things that will make development a lot easier. So for instance, a lot of times you take a single large Arduino Mega and you try and run multiple sensors off it, let's say. You want 4 infrared sensors, you run them off the same Mega. You want 12 solenoids, you run them off the same Mega, which works fine for 1 unit. But when you talk about taking that from 12 units to, let's say, 100 solenoids, you now have a big problem. Because are you going to buy an MCU with 100 pins? So my sort of train of thought now has been to moving to as many nodes as possible, to the point where if I have to build a unit with 12 solenoids now, I will get 12 different microcontrollers and network them together, which is simple on paper, but when you talk about how do you network it consistently and yet quickly, right? You can't be building out your comms protocol for every iteration. There comes a problem here. And there are also other parts that will be useful, so things like configuration. So you might be going to a work and saying that I want to adjust this brightness for the specific room. And you can't be going to refresh 30 ESP32s. You want a way to broadcast settings throughout everything. So likewise, you want visualizations for your sensors. When things trigger or when things don't trigger, you want to be able to say that this was because of a sensor that saw something and it shouldn't have been there, right? I should filter it out. So how can we do this? So ESP32s were my favorite until price started going up. You couldn't assemble them, so trade-offs there. So that's a different topic. So I started looking at scripting languages. So there are many options, right? You have Lua, which is your standard one. You have MicroPython. You have Tuit. These are very specific targeting ESP32s. And they have their pros, they have their when you're talking about this kind of setups. But the problem here is that Arduino is C++. If I move to Lua, I lose the ability to port libraries to it. I have to rebuild it entirely in C++, or I have to embed it into my firmware. So there are trade-offs there that made me a bit hesitant to adopt Lua. MicroPython has the same issues. So other than a Python bit, MicroPython is something you embed your project into, right? If you play with MicroPython, you kind of understand what I mean when I say that it's kind of hard to embed a MicroPython runtime into your project itself. It's not built to be carved out that way. So again, I've been dragging my feet on this. But there are benefits to using a scripting language, right? You can upload just the bits that you need, just the application level stuff. Your drivers, your Wi-Fi, your communication can be embedded in your base firmware, and you only change that behavior as fast as you need to. And the second thing is that it's much harder to break units when you write bad code. So I had an experience where I shoved ESP32s into LED signs, screwed them dead shut, and I have updating over Wi-Fi. I pushed a bad update, it went into a boot loop, and whoops, I have to unscrew it, reflash it, and fix the thing. So I like to not break my units that often. So yeah, these are the topics I've been talking about. So I came across WebAssembly recently, and WebAssembly is interesting because it targets modern web browsers and allows you to compile C, C++, or other languages to it, meaning that you can take, let's say, a generic hello world, compile it for a web browser, and run it on a web browser. The interesting thing with WebAssembly, contrary to its name, is that apparently there are a lot of runtimes for it, right? This is WASM 3, which hasn't been developed well recently because of the Ukraine war, but it's a different story again. But interestingly here, it not only targets your web browsers, targeting actually OS directly, and even targeting microcontrollers, right? And you can see that the minimum useful system requirements here, targeting 64 kilobytes of code, is something that I could fit into MCU very easily. 10 kilobytes of RAM is acceptable, yeah. So this comes to what I've been trying to play with. So instead of running C++ directly on an MCU, I am building a WebAssembly application and then running a WASM runtime on a microcontroller. So you compile on a PC, but you run your application on an MCU, and I define in my runtime functions that call the peripherals. So for instance, reading, writing the GPIOs, reading, writing the comms interfaces, or even talking over a CAN bus to other devices. So these are built into the base firmware, and then my WebAssembly application is like sub 64 kilobytes, and that gets uploaded much, much quicker. So I won't talk about the plus because evidently it works, but I'll start talking about the minuses. So one very common limitation, especially through other interfaces like Lua, is that you can't really pass C++ members to it as a native function. So when you want your Arduino very nice serial.write, you can't really do that unless you abuse structs badly. But in this case here, my mitigation is to implement the shim in the WASM application layer. So my application layer has my nice C++ classes, but I have just pretty poorly written C shims that call the underlying functions. So this underscore serial underscore write is the actual native function passed to the WASM runtime, but everything here in this slide is part of my WASM application. So I have just a little bit of overhead for calling each function, but I don't have the underlying actual serial comms passing through the WASM stuff. The next kind of major issue I found is that WASM doesn't really support interrupts, meaning that you can't have an application that you're running and say that I want to interrupt it here and jump my execution point to some other function as an interrupt happened, right? So it's an ongoing discussion in the WASM ecosystem, but my mitigation here is to handle the ISR in the actual base layer. And the WASM application just polls it constantly. Every time the main loop runs, it just checks, did the interrupt happen? Did I receive a message? Pull the message if I did. And the other bit is that there's not really a way to limit how often or how the WASM application runs. So if anybody's familiar with Ethereum and its concept of gas, meaning that you have a limited amount of gas for each contract that execute, and beyond that, your contract execution will fail. I wanted something similar here, because if I write a bad while loop, I could break the MCU, right? It might just go in the while loop and I can't unbreak it. So there's no clear way to do this, not any of the runtimes yet. So that's a problem, but you can easily fix it, right? You don't run your WebAssembly app until, let's say, 5 seconds after you boot. So you have a couple of seconds to interrupt it if you do write a bad app. And along the same lines, there's no way to really terminate the execution of a WebAssembly application once you run. So these are kind of meant, I think, to be short-lived, validate, compute stuff on an edge device or something. It's not really meant for you to run a constant loop. And if I want to restart the application, be able to terminate and restart it. So my mitigation here, and it's controversial, and I love to hear other solutions, is I call my WebAssembly application in the FreeRTOS task, and I kill the task to stop it. So obviously here, there are the implications about cleaning up. How do you handle freeing your memory? What happens if you put peripherals in strange states? And I'm just wiping everything out. So I statically allocate all my structures that I use in the WebAssembly app, and at the end, I just toss it all away. At the start, I reinitialize all my peripherals that I use, and it seems to work well enough. So putting it all together, this was an art installation shown at Ars Electronica a couple months back, And this was running on 13 Raspberry Pi RP2350s, and they were running WebAssembly. So the application you see, where there are a bunch of lights bouncing through different vessels, is running on WASM. And along the way, on each node, there's a small radar sensor, again pulled by the WASM app, that lights up different lights when people walk through. So this was the first real test of being able to run a higher level scripting language on a bunch of nodes in a kind of, I would consider, a production environment. And it went pretty well, other than really strange things like running out of memory, because WASM allocates like 128 kilobytes pages by default, it seems. So still some work to do. But so yeah, so it's a bunch of RP2350s, a radar sensor, and then a CAN bus talking, linking all the nodes together. So with this in mind, I have another event to plug. So this is done in collaboration with National Arts Council. And one of the things they want to teach is to incorporate more technology in art. So we are sort of having an open discussion at one of the newer NAC venues. They're trying to open a RX Tech Lab, and we're trying to bring together artists and engineers to hopefully work together on this kind of projects again. So grab photos if you like. I hope to see you there. That's all I have. I will take questions or yes.
So a comment on your terminating WASM by killing the process. Yes, have a look at crash-only design. This is something that's not well understood. The programmers tend to want to write a thing that says, we start with a clean environment and we have our startup, and we separately have some sort of recovery path for use if and only if the system is broken. This is a fragile way of writing software.
Yes.
A better way of writing software is that the only startup path is the one that deals with recovery from arbitrary misconfiguration, fixes whatever it is, every start.
Yes.
It gets tested every run and also recovers. If you do that, it is then reasonable to terminate by just doing immediate judgment.
Yep.
So it's a yes, to answer your question, but have a look at crash-only design.
Thanks. So for context, he just mentioned take a look at crash-only design to make sure that things start up cleanly every time. Yes. Hi.
So I have a question. So you mentioned that you wish there was a way to limit how long the WebAssembly process runs.
Correct.
You also had this note about the interrupt handlers not doing it well. But I wonder if you could solve both of these by just inverting control and basically saying that what I write in WASM is not a single process that inside does an infinite loop, but rather it's a thing that will get called from an outside infinite loop, and then maybe instead of just running that loop iteration, if you have an interrupt, you can decide that, okay, instead of other WebAssembly functions. So can you talk about this kind of design?
I've considered it, and it's on the to-do list to investigate, not only because of what you mentioned, but because it will be useful to be able to run multiple loops simultaneously. Because I don't want to have to do the multitasking, in the very poor Arduino method of millis. It's annoying. So I was considering at some point that if I have multiple loop functions, I could technically run them in separate tasks and at the same time get this for free. Yes, thanks. Sorry.
Yeah. Okay. I was thinking, why wouldn't Zigbee be a better alternative? Because Zigbee runs very deep and it can be communicating across it. It can centralize key control.
Sorry, I couldn't hear what solution you're proposing. Like what?
I'm just wondering about why don't we use a Zigbee chip?
Zigbee?
Used to also have the
Correct.
H2 and the C6.
Yes.
The Zigbee chip.
Yes.
So if you write it over there, it's more optimized and you can actually do a connectivity between the DSP process.
So it's for the very simple reason that I don't trust wireless networks in hostile, unknown environments, because I often work in setups where I get access to the venue 1 week before deployment. And if I get into trouble because of wireless networks, I am in huge trouble to redesign it right there. So for this reason, I've moved to a CAN bus, which sounds a bit overkill, but I think it's worth the nightmares that it saves me. Sorry, I think you have a question.
In all your explanations, where does the WebAssembly part of the code sit? Is it part of the microcontroller?
Yes.
So instead of like uploading an Arduino sketch, it's actually the Python code.
Correct. So at the moment it's unicast, so I have to pull every unit one by one, but it could be trivially made to be able to multicast it. As I broadcast the application, everybody listens and update for it. Yes. Any other comments? Or we can take it to after, because I think there's another presenter. Yeah. Thanks for your time, everybody.